Swayam Prabha. Digital India. Educated India.
Good morning. Welcome to the second lecture of this week 7 for the ongoing course on understanding and reducing greenhouse gas emissions. We are looking at building design and construction to reduce the emissions, especially focusing on scope 1 and 2 emissions. We are going to look at material selection for emission reduction today. Now, what we had discussed in previous lecture, yesterday's lecture, was that we were looking at all the factors that affect the selection of material. So, we discussed about a lot of parameters which concern mechanical and non-mechanical performance parameters. Then we looked at economic parameters. We also looked at the aesthetics and then a number of parameters under the umbrella of sustainability. So, we looked at all of these parameters and we clearly saw that the selection of a material is actually a result of discussion on all these parameters. And of course, what will happen in reality is that some or the other parameter will take precedence, will be more important as compared to the others. Now, what we are going to look at today is we are focusing only on one specific part of these parameters. We are largely focusing on the sustainability part, and there we are looking at the emissions that are associated with the materials. Now, when we say we are looking at emissions, before I go, I am going to give you an overview of what all different materials are, and then we will look at their emission numbers. That is primarily what we are going to do in this lecture. But before I start to do that, we have to understand that how are we getting these numbers, where are we getting these numbers from. So, when you will see the numbers, you will see that the industrialized products, which are very different from the raw material that is actually going into the industry to make the material, they will always have higher emission numbers. Now, this emission that is associated with the material is through this entire process of manufacturing. It is scope 1 for this industry which is manufacturing a material. So, for example, if we are talking about say brick industry, fired clay brick industry. So, all the emissions, combustion of fuel on the site that is taking place is scope 1 for this brick manufacturer. But when we are using this material brick into our buildings, then it becomes scope 3 upstream for us, because it is something that has already happened. It is already embodied. The energy that has been wasted, we call it embodied energy. So, it is not the amount of energy that is actually contained in the material, but this is the energy that has been consumed to produce this material. So, we have these emission numbers coming from the combustion of fuel, one, and second is processes. So, sometimes we will use certain chemicals to clean, to bleach, to process certain materials. So, one is combustion of fuel. Large amount of emissions are actually taking place for combustion of fuel. The second one is where we are talking about process emissions. So, different processes will take place. We might be using acids or some other specific gases or some other materials which when react with other agents will release certain greenhouse gases. So, this is part of processes. They are lesser, but not totally insignificant. So, it is roughly around 10% is what we will see for a lot of different materials is, and of course, it will vary. So, these are the emissions that we are talking about, and this is what we are going to see when we see emissions for different types of building materials. Now, if we look at the overall carbon emissions percentage building material wise, we will see that the three materials which take the center stage in today's times, one is cement. Cement is the most energy consuming or emission producing material that today's building industry is using. The second one is, so here when we say ceramics, we have placed glass along and then steel. Steel and glass is almost equal. Now, if you look at the kilogram percentage, like the actual weight percentage of these materials, we would see that it is much lesser. If you compare it with the concrete, the weight of concrete itself by volume, it is much higher than the percentage weight of steel and ceramic or glass that is being used in the buildings today. But the embodied energy associated with these materials is extremely high, and that is where we will see that the carbon emissions, if we are considering percentage wise the building materials. So, these are going to be significant, but of course, due to by virtue of the volume of concrete that is going into our buildings today, cement is significantly higher. There are a lot of other materials which are there, but we would see there are materials which are industrialized products, and we also have materials which are not industrialized, which may though require processing, but we have a wide range of these materials which are slightly less significant. So, what we can clearly see is that there is a huge percentage contributed by cement as far as overall carbon emissions from building materials is concerned, and we can look at this plus these two materials. Now, what all can we do about them is it requires a deeper investigation into this. There are researchers, there are industries which are working on one, reducing the emissions during the manufacturing of cement. There are also works going on in developing different types of concrete which require lesser amount of cement, because if you look at the concrete composition, so cement is the constituent which actually adds to its emission intensity or carbon intensity. The other materials have very low emission intensity. So, what we are actually seeing is that if in concrete, and cement is largely going for concrete plus of course the mortar. If we are looking at concrete and if we can find a replacement to cement for making the same concrete, getting the same strength, then we would be able to reduce it significantly. And whatever amount of cement is used, that too if it has lesser intensity, that will overall reduce the emission intensity of buildings. Now, coming to the construction materials, we can clearly see that the materials which have a very high carbon footprint, emission intensity, are the ones which are manufactured in industries. So, let us look at the peaks. We are looking at PVC pipe, plastics basically. Now, these have the highest carbon footprint, they have the highest emission intensity, but the saving grace is that this material is going to be used in very small amounts in a building. The percentage of its usage is significantly lower, but we can further reduce it. But if we look at the other two, which is steel and aluminum here, now they have significantly higher, of course much lower than PVC pipe, but significantly higher than other building materials, the carbon footprint or emission intensity. Now, when we look at these two materials, we also see, and the trend that is going around, that the trend of usage of these materials is increasing day by day. So, it is not just for structural purposes that we use it for aesthetic purposes, for cladding and several other purposes, and there it is going to increase the carbon footprint, the emissions related to buildings as products significantly. If it is going only in structures, for example, the steel is going into structure as a structural component for enabling reinforcement or providing reinforcement, there the volume of this material used will be significantly lower. The moment we start cladding our buildings entirely with these metal sheetings, it is going to become, percentage wise, its consumption is going to be significantly larger. So, that we have to see where we can control. The others also, if you look at this, so the metals are usually higher. So, you can clearly see that the metals, production of metals will always consume more amount of energy and also release more emissions. So, we are looking at the metals which have, so excluding these 3 which are the top ones, excluding these 3, the next most intensive materials are metals. So, we can reduce the usage of metals in our buildings. If we are able to do that, we will be able to reduce the intensity, emission intensity of the buildings. The next we have paper, again manufactured industrially now. Then we have tiles, ceramics, we have glass which comes next. So, we have glass wool, we have ceramic tiles, we also have plywood. So, it is different from wood, it is processed, there are a lot of synthetic materials which are added to it. So, after metals we have tiles and glasses. So, we are looking at glass, plywood, glass wool and ceramic tiles. So, these go as the next category. The smallest, the tiniest footprint is that of the natural materials. So, if we are looking at stone, marble, or if we are looking at wood which is naturally procured, but not industrially seasoned. So, if you look at this number here, we will see that timber is still having a higher intensity. That is because the wood that is being procured is being seasoned in industries. So, we season them, we keep them in these seasoning chambers for several days, where there are alternate cycles of heating, cooling, and then adding different compounds to them, spraying them with different compounds, so that they are seasoned well, different types of oils and all. And there we are releasing a lot of greenhouse gases during the processes, and also consuming a lot of energy to keep them at a certain temperature. So, when we are talking about timber here, we are actually talking about seasoned timber, so not wood. If you look at now, the lowest, as I said, is that of naturally available raw material, but if you also look at the smallest number, we can see that we have concrete and brick which is at the bottom most. So, bricks, though they still have it is not absolutely 0, and it is higher than a lot of other naturally available materials. For example, if you are going ahead with adobe construction or mud blocks, so there the emissions are practically going to be close to 0. But if we are looking at other factors of material selection, then we will see that brick and concrete still have significantly lower carbon footprint. Now, we can see here is this concrete having very low carbon footprint, but it is still there, and within that, as we have already seen, cement is the largest, biggest contributor of whatever number we are getting for concrete. Cement is the primary contributor to this emission that is associated with concrete. Now, this is an overview of carbon footprint of different construction materials, and we can make a judicious choice of which material to use and what all are the options that are available to us. If we are looking at a building and then looking at composites of the material, so not individual building material, but composites, then we see that concrete. Now, here we are talking about buildings which are not using brick. So, we are assuming that the walls are being made out of concrete, thin panels of concrete with insulation. So, predominantly how construction in America, United States of America, and couple of European cities would be happening, unlike what it is how construction is happening in India and the Asian countries. So, we see that the largest share of this emission from a building is coming from the consumption of concrete, which is what we have also seen, that there was this cement which is primarily responsible for the emissions from the buildings, and that cement is actually going in concrete. The next is insulation. So, as I said that we are talking about colder countries, we are predominantly talking about this number is coming from USA and other developed countries, there the which are predominantly cold. So, we are looking at insulation, provision of insulation, because we are using concrete for walling, and then we are adding insulation on top of that. So, insulation is adding a significant amount of emissions to the building. Then we have cladding. Since we have thin panels, sometimes we do not even have concrete in the walls and it is all dry construction. So, then the next is cladding. So, since it is just a frame, non-structural part I am talking about. So, there is structural frame where the concrete is going, and the infill, the walls are actually happening with the help of the structural frame using wood or aluminum or some other metal, and then there is insulation and cladding on top of that. So, cladding also takes significant percentage of the total emissions, around 12.5%, followed by windows. Now, windows, one that we have to understand that in cold countries, windows are significantly larger if you look at the total area, and in windows we are primarily looking at glass and frame. So, frame is also emitting, highly emitting as a manufacturing process, and glass also has very high emissions associated with it. Then we have framing. So, we are talking about different types of frames, but not windows, and then interior surfaces, which is almost equivalent to cladding. The other insignificant components are those of structural and roofing. We are talking about sloping roofs predominantly, and the roofing sheet on top of it, that is what we are talking about as roofing. So, clearly we see that concrete occupies largest space, and then we are talking about all industrialized materials which are taking the which are giving us the emissions related to buildings. Now, let us look at different low emission materials. In fact, we look at the entire range of materials that are available for walling, and you can clearly see that which materials are associated with low emissions and which ones have high emissions. And the facades that we are going to get with them, they can all be equally beautiful. So, it is not that certain specific materials only can help us in creating aesthetically pleasing facades. It is about perception, as I have been talking about, but there are options, and the buildings with all different materials can look equally aesthetically pleasing. Now, here look at how the numbers are varying. Starting from rammed earth, as I said that it is very low a number. So, looking at rammed earth, which is a natural material. So, all we are using in rammed earth is we are excavating the mud, the earth, and we are ramming it in the specific site, on the specific site. So, it has the least amount of carbon footprint, the GHG emissions associated with it. We are talking about only 48 kgs per meter cube of rammed earth construction. As we go further, softwood timber is almost double of that, laminated timber is further up, which is close to 200 kgs. Then stone is closer to this. Now, stone is a natural material, but there are a lot of scope 1 emissions that are going to be associated with stone, because we are cutting, we are using machines to procure stone, extract the raw material, and then also to dress it to provide us in the form of sheets or blocks. So, all that processing will require a lot of energy, fuel to be consumed. So, the machines are going to consume energy, not the raw material itself, not the processing of raw material. So, it is close to the laminated timber here. And then comes clay brick wall. We are talking about around 350 kilograms per meter cube when we are talking about a fired clay brick wall. Now, look at this number, and now we go on. So, reinforced concrete is almost the double of it. We are talking about reinforced concrete where steel is being added into it. Then we talk about glass, which is at least 6 times, it is causing 6 times the emissions as compared to reinforced concrete despite the steel going into it. So, what we have here is we have glass at 3600 kilogram per meter cube. We are talking about the carbon emissions. If you look at steel section, it is multiple times higher as far as emissions are concerned, and aluminum is even higher than that. Now, these could be used for walling, these could also be used for roofing, but you look at how the numbers are going up if we are only looking at the options that are available to us for walling. So, we can clearly look at these numbers and of course, place their mechanical properties, their performance criteria along, and then select the materials appropriately. This is what we are emphasizing here. There are several databases which are available in the world today, and these values will also vary from country to country depending upon the processes, the efficiency of the process that is employed for manufacturing a certain material. So, if you look at how bricks are manufactured in India versus how bricks are manufactured in UK, you would see that the numbers would vary. The kind of fuel that we are using and the kind of fuel that is used elsewhere, that will bring about the difference. So, when we are looking at these numbers, the overall GHG emission associated with a particular product, industrialized product or any other building material, we have to see where are we procuring the material from, and associated to that, if there is a database that is available, we check for those numbers. So, again the similar thing is you can clearly see here that we clearly see that bricks are not the least emission causing material, but overall if you look at the usage in the building, and so concrete is lower. If you look at the concrete block, it will be much lesser than the fired clay brick for the same volume, but what we see, the moment we add reinforcement to it and it becomes a reinforced cement concrete, the overall emission intensity is going to go higher. But overall if we see, the clear understanding is that the raw materials, if they are not processed at all, are going to have least amount of emission, and as the processing goes up, we are going to have more and more emissions to be added to them. Now, if you look at roof materials, now here the materials that I am discussing here are mainly the sheeting over the sloping roofs. If we are talking about flat roofs, again what we have the concrete as the base material. On top of that, we will have different types of these roofing materials which are going to be used as sheeting, and we are comparing with that, plus we also have green roof. Now, as a perception, we would think that green roof is the best because it has so many other benefits, but if we look at the emission aspect of it, if we associate the emissions, then we would see that the green roof probably has a higher carbon footprint. It is associated with higher emissions as compared to a traditional roof. And why would that be? Because there are multiple layers. If we really want to make the green roof function well, we will have to add a lot of insulation layers beneath it. So, there will be multiple layers for waterproofing, and there will be layers for insulation, and then we will be adding an extra sheet to hold the earth, the clay, that is the soil that is going to be used as medium for growing plants, and all this together is going to give us higher emissions. Now, this is emissions. If we look at the operational benefits, the savings in operational energy over the years, so of course, there we have to make a choice. So, we have to not just look at the initial emissions and the cost that is associated with it, we have to look at the cost benefit analysis. So, what after 5 years if I have a green roof versus a bare roof with probably a clay tile on top of it for waterproofing? How much energy am I going to save from a green roof as it absorbs all the radiation that is incident on it? It creates a cooler environment, indoor environment. So, we have to weigh that the emissions that are going to be there at the initial stages compared with that of the entire life cycle where operational energy consumption and the emissions associated with it are also going to be there. If we look at the materials, the other materials, again we will see that the industrialized products that are going to be there and metals are going to be high on emissions. So, metals, plastic polymer is going to be the highest, we are going to have the highest number for that, followed by metals. So, highest is plastic, followed by metals, followed by, if it is industrially treated wood, we will have wood coming next, and after that we will have say clay and concrete, followed by the stones. So, it is the similar pattern that we would see when we are looking at different types of these materials, but the perceptions have to be kept aside. We have to clearly see the numbers as we have just talked about in case of a green roof. It is not going to be a very low emitting roof, it will be associated with higher emissions, but the operational benefits, the energy savings for the operational time, so life cycle benefits are going to be higher. If we look at floor, again we are looking at multiple options. We have tiles which are manufactured, we would be having wood flooring, again there could be natural wood, seasoned, treated, floors, definitely the floor tiles, wood floor tiles, they have to be treated well, because they are exposed to a lot of weathering, they are exposed to a lot of different components unlike walls. So, engineered wood would be higher emitting, it would have higher emissions, and laminated wood would have even higher emissions, because it is now laminated with a synthetic compound. So, that is further adding the emissions to it. Mosaic flooring will be having lower emissions as compared to the tiles and wood flooring. The natural stone flooring, we might be seeing that stone otherwise is associated with lesser emissions and lesser energy consumption, but the natural stone flooring, since we are making thinner tiles out of a stone block, it is going to consume significant amount of energy and fuel for the processing during the process of making the tiles. So, this is not going to be very low as compared to the stone in walls, because we are using bigger blocks there, and here the tiles are becoming very thin, and we have to make them very smooth, and we also have to polish them. So, all that is going to give us slightly higher emissions. And then we have a lot of other materials such as leather or epoxy, or we also have glass floor tiles. Then we have carpets, we have cork boards. Depending upon the industrial processes that have to be done, that have to be there to produce a material to this state, the emissions will be directly proportional to the industrial processing that the material is subjected to. So, if you look at the numbers again here, if you look at marble, it is much lower, terrazzo and marble are the lowest emitting if you look at these materials. The next one would be clay tile. So, this requires higher manufacturing. Now, why is clay tile having a higher energy or emission intensity and not the bricks? This is for the reason that the clay tiles, when they are being manufactured, there are a lot of challenges for overcoming those challenges. For example, all the tiles have to be absolutely flat, unlike bricks which may slightly be deformed. Okay. So, we require a whole infrastructure to get flat tiles of absolutely the same size and shape, and then they have to be finished smooth. So, a lot of processes are going into making these clay tiles. The material remains the same, more or less the same. The firing process and the energy consumed in firing will also remain the same, but the processes before that are going to consume way more energy, and they are going to release more emissions than the regular fired clay bricks. Then we have say rock wool slab and ceramic tiles, which is again coming the next. So, ceramic tiles are almost double the clay tile, but they are still much lesser than that of vinyl flooring. We are talking about synthetic materials here, which are fully manufactured in industries, and of course consume a lot of energy and release a lot of emissions. Then we are following it with wool carpet. So, now you may think that wool is if it is a natural wool carpet, it is a natural material, but the processing of wool, washing, cleaning, making it durable. So, the processes which are required in doing that, they have lesser combustion emissions which are resulting due to combustion, but they have very heavy process emissions, because the cleaning, the agents that are used, they release a lot of greenhouse gases, and not carbon dioxide probably, but gases which are way more potent than the combustion of fuel. And then lastly, we have materials such as carpet tiles or nylon, again synthetic materials which are even higher than them. So, overall if you look at tiles, we will see, and which is what I was telling you earlier. Now, I am only adding the data which is available in authentic resources and which is properly reviewed. You could find a lot of other data also which you can go through. Now, here for tiles we are looking at that almost 90% of the emissions are coming from combustion, and around 10% of the emissions are coming from processes. This is in general for ceramic tiles. If we are looking at the wool carpet, then this number might almost reverse. We might be having much higher process emissions and much lower combustion emissions. Now, when we have all these materials, what do we do about them? So, there are researchers, people who are working on very interesting new materials. So, there is this company called Carbon Craft, and there are several companies like that, where what they are doing, they are sequestering, they are absorbing the air, they are extracting the carbon that is there in the air from the carbon dioxide, and they are compressing, they are using the pollutants which are extracted to make the tiles, which they call as carbon tile, because it is largely carbon that they are able to extract and then compress it back to give a solid shape in the form of a tile. So, it is, so there are, we do not have the data on how much emissions are they causing, but if they are able to sequester a lot of pollutants, a lot of carbon from the air, overall their emission intensity will go negative. They will be sequestering, they will be absorbing more carbon than their processes would be releasing. Now, coming to fenestration, fenestration would have two parts, as I said. One would be the frame. So, we have different types of frames, aluminum, vinyl, wood, steel, wood clad and composite. Again, clearly we know that aluminum and steel are going to be the highest emitting frames. But we have to look at their strength, their durability, those factors. For example, the steel is not appropriate for coastal areas because it corrodes, it rusts. For coastal areas, even wood is not, if it is not seasoned well, this will give us problems because of the fluctuating humidity in the atmosphere. It is good for dry areas, but what is good is aluminum and probably vinyl, because they are unaffected by the moisture that is there, and also they do not corrode, both of these materials, but both of these materials will then be associated with very high emissions. So, similarly for all other materials also we have to look at all other factors which we discussed yesterday, but we clearly understand that metals are going to be highly emitting, they will be associated with high emissions. Vinyl, the synthetic materials would be almost close to these, and they could be even higher. The numbers that we have seen, PVC pipes were way higher. So, vinyl would be probably the highest, followed by metals, and then followed by composite and wood clad, and lowest will be that of wood. Now, if we come to glass, so the glass, more or less different types of glasses will have similar emissions associated and very similar embodied energy. Overall, if we look at the embodied energy that is associated with glass, it is higher, but also consider the amount of material, the percentage of total volume of building materials that are going in a building, glass is significantly lower as a percentage. So, the overall emissions that are there due to a building, glass is an insignificant contributor comparatively. And if we are comparing the overall life cycle cost, and if we are looking at the overall life cycle emissions from the building as a product's life cycle, then we would see that there are more benefits, more savings of scope 2 emissions as compared to the upstream scope 3 emissions due to these different glasses. So, we are talking about single glazed, double glazed, triple glazed. We also could be talking about different types of glasses. So, there could be clear glass, there could be tinted glass where some metals might be added to give it a particular shade or tint, or we may be having a hard coat, or where the glass is made reflective by spraying some compounds which are usually metallic compounds on a hot surface of glass, or they could be soft coated, where they could be low emissivity coats. Again, some metals and specific nano compounds are sprayed on top of the glass surface when it is cooled down. So, there are these varieties of glasses, but the largest percentage of emissions, they happen during the manufacturing of the glass, when the glass is being fused from the raw material to the form which is known as glass. All other additional processes they will cause very less amount of emission. So, most of the glasses would have emissions which are fairly in the same range. So, it does not really create a lot of difference in the overall emission scenario if we choose one glass to the other glass, but it will create a significant difference in scope 2 emissions because of the performance, the thermal performance and the visual performance of this glass. So, whenever we are calculating the scope 1, 2 and 3 emissions for any business, any company, we have to clearly know the processes that are associated even with the materials that are going to go into the making of the building specifically. So, we will stop here, and I hope that we have a clear understanding of how choice of material will play a role in controlling, in reducing the overall emissions, but we have to clearly see that all that we discussed here largely was on embodied carbon and embodied emissions. So, that have happened as scope 3 for the building or the company ahead, but their thermal performance, their visual performance, it will affect the scope 2 emissions. So, we do not have to stop at scope 3 emissions upstream, we also have to calculate the scope 2 emission to overall assess the selection of the material, the performance of the material, and how we need to select it appropriately. Thank you very much for being with me here today. Bye bye and see you tomorrow.